Welcome to Limits, Lesson 1, Introduction to Limits. So why don't we go right ahead and look at the definition of a limit. Right there is the formal definition of a limit as you would see it in a college course. And I'll go ahead and let you take that in. And if you didn't pause it, good for you, because you don't really need to write that down for my class. Instead, we'll just go ahead and move on to the next page. And the rest of you that stopped it, well, I guess that was my first joke. So let's go ahead and move on to an informal definition and understanding of a limit. Limits are the f of x or y value you will approach as you approach the given x value. First of all, let's go ahead and review what we know about asymptotes. What is the vertical asymptote of that rational function? Okay, the vertical asymptotes, as you've already figured out, x equals 1 and 6. The horizontal asymptote, y equals 2. Okay. Now to find limits, what we're going to do is we're going to approach a value and see what the given y value is. So let's let x equal 0. No, not let x equal 0. What is the limit as x approaches 0? What is the limit as x approaches 0 of f of x? What is that limit? That's what we're going to explore today. So let's go ahead and move on to the next page and talk about limits a little bit farther. Our function f of x equals x minus 3. So let's go ahead and try to figure out what the limit of f of x is as x approaches 5. Okay, from the left-hand side, we'll keep on getting closer to 5 and see what happens. When you put in a 4.9, you get a 1.9. You get a 4.99 in there, and you get a 1.99. Put in a 4.999, only 1,000th the way, and you get 1.999. Let's go ahead and put a 5.1 into that function, and you get 2.1. Put in a 5.01, and you get a 2.01. Put in a 5.001, and you get 2.001. So intuitively, it looks like the limit of f of x as x approaches 5 is 2. And actually, analytically, it is that. Let's go ahead and move on to another function and play around. Alright, this time we're looking at a rational function, g of x equals x squared minus 8x plus 15 all over x minus 5. Now I'm not sure that you will be able to do those in your head, so what we're going to do is I want you to go to second window and make sure that the table set is independent variable ask and dependent variable auto. Then go ahead and put this function g of x in for y sub 1. And then when you get that entered in, don't forget to put parentheses around that denominator x minus 5. And put parentheses around the trinomial in the numerator before you hit the division bar. And then I'd like you to go to second graph where the tables are, and we'll start entering values in and see what happens with this function. So go ahead and do all those things. Put that function in for y sub 1. Make sure that you do second window and make sure independent variable ask, dependent variable auto, and second graph. I'm going to pause. Alright, we're going to use this table to find the limit as x approaches 5 of g of x. We're going to use that table. So first we're going to put in a approaching from the left 4.9, 4.99, and 4.999. When we put those values in, the calculator will automatically put out a 1.9, a 1.99, and a 1.999. Then as we approach 5 from the right, we'll put in a 5.1, 5.01, and a 5.001. And isn't it cool how that calculator just kicks out a 2.1, a 2.01, and a 2.001. I think by looking at the table values that we just got, it's pretty safe to say that the limit as x approaches 5 of g of x is going to be 2. And we'll talk about later about not just putting in values to your calculator with a function, the table, to find out how to find limits. But you got to learn how to do it the hard way first. Alright, now let's go ahead and look at h of x, a piecewise function. Oh, don't you guys just love piecewise functions? Alright, and again, we're going to try and find the limit of h of x as x approaches 5. So we're going to put in values. This time you're just going to have to choose which one of these three you're going to use depending on what number we put in. I'll give you a paper in class if you really want it on how to enter piecewise functions into your calculator. It's actually pretty complicated, but if you want it, I'll get it for you. Alright, let's go ahead and approach 5 from the left. When we put in a 4.9, I think it would go into there because it's less than 5, and we'll get 1.9. Put in a 4.99a, it's still less than 5, we'll get 1.99. Put in a 4.999, and you'll get 1.999. Alright, now let's go ahead and put in from the right a 5.1. Hey, that's greater than 5. We now need to use this one. We'll get 2.1. 5.01, we'll get 2.01. And when we put in a 5.001, we'll get 2.001. It's pretty safe again to say, looking at the table, intuitively it looks like the limit of h of x as x approaches 5 is 2. So, and analytically later on this week you will find out that that limit is actually 2. Alright. Limits can also be one-sided. If you're going to approach 3 from the left, as you write the limit down, you're going to write x approaching 3 with a little minus sign up there. And if you're approaching from the right, you can write a little plus sign right where that 3 is. So say, look, this one is approaching from the left because we're coming from the negative side, and this one's coming from the right because we're coming from the positive side. And now we're going to find out what limits, or when a limit actually exists. Okay, let's go ahead and look at the graph of a function, and we'll talk about limits. Okay, we have a beautiful f of x here. First of all, I'd like to look at and see if you can figure out by looking at the graph of f of x what the limit of f of x as x approaches 5 from the left. What does that equal? Yeah, okay. If you said 5, you were correct. And what is the limit of f of x as x approaches 5 from the right? Yes. That limit is 7. I'd like you to look at another point. What is the limit of f of x as x approaches 11 from the left? Good, you're getting better at this. 2. And what is the limit of f of x as x approaches 11 from the right? Good, that is also 2. So, having said that, what do you think is the limit of f of x as x approaches 5, and what is the limit of f of x as x approaches 11? Well, in order for you to answer these two here, the writing in black, you need to read or watch as I uncover. Are you ready? A limit as x approaches a number, a constant, exists if and only if the 3 following conditions are satisfied. That the limit from the left exists, that the limit from the right exists, and we've seen in the last both of the blue writing up here and the blue writing up here that both of those first two conditions are met. And the third condition is that those two limits from the left and from the right have to equal each other. So, the limit of f of x as x approaches 5, that limit does not exist! You cannot believe how long I've been waiting to say that. And you think I'm a mean girl. I don't think so. I'm a mean guy instead. So, this limit, DNE, does not exist. The limit of f of x as x approaches 11, that limit is going to be 2 because it's 2 from the left and from the right. Okay, now I need to speak a little faster because I ran out of my time limit and had to start over. The limit of f of x as x approaches -7. There's two philosophies. You can either say it does not exist or it's negative infinity, because as you look at the graph, when you approach from the right, it goes down to negative infinity. When you approach from the left, it goes down to negative infinity. So some people would say that the limit is negative infinity. Other people would say it does not exist. Alright, it's kind of funny to think that the limit is not limited because you're talking about infinity. And I've got about 15 seconds to wrap up. Hey, have a great evening, and I'll see you tomorrow morning.